Hi guys, welcome back to the channel, and in today's video I will be sharing with you a revision checklist for quantum chemistry and chemical bonding paper, that is a core paper of 5th semester B.Sc Honours in Chemistry at Delhi University. Basically, when I was preparing for the exam last year, I felt that I should have compiled a whole list of topics that were repeatedly asked in the previous year question papers, and keeping that in mind, I have compiled the whole list of questions and topics that have been asked in the previous 5 years. And so let's start with the checklist, and I'll be highlighting the points that are important. So firstly, we'll have a look at the operator and commutation rules that is also asked very frequently. The first one is the fundamental quantum operators, that is momentum, energy, and potential and kinetic energy. Second is the commutative relations, like the relation of two functions being commuted, like when they are operated, and the result, whether they commute or whether they do not commute. If they don't commute, then like what is the result if they don't commute? That might be asked. You can be given two functions, and they can ask you like what is the result of this commutation of these two functions. The third is properties of acceptable wave function. This is an important topic. You need to learn the properties of the acceptable wave functions. You can be wave function like phi x can be given as in the previous papers, like e ki power minus x plus e ki power x upon 2. This was given, or something of this sort, and you can be asked to write if the given wave function is acceptable or not. So you need to check about the like, is it differentiable, is it square integrable, is it single valued. So like this, you might be given two or three functions, and you need to check them if they're correct or not. Fifth is the eigenvalue. Like eigenvalue equation, we know that a cap phi is equal to a phi. So finding the value of this a cap, you can apply the operator and then get the eigenvalue function or the eigenvalue to this eigenvalue equation. So this can also be asked. Normalization condition and orthogonal condition, like the functions can be given, and you might be asked to either find the normalization constant, or normalize the function, or the conditions for the normalization. This can also be a theory question, or this can be a numerical also. So basically, normalization condition, orthogonal condition, like the condition that psi a psi b is equal to 0. This is the condition for orthogonal, and the normalization condition is integration of psi a psi b is equal to 1 over the whole limit of the integral, whatsoever that is. Or you can be given a function, and you will be asked to normalize it. So that is also a good question that is frequently asked. Moving on to the next topic, the particle in a 1D box model. This is a very important section of the syllabus. Wave function of a particle in a 1D box, you have to learn the expression of this. Derivation can also be asked, or directly it can be asked to express it also. In this, you can also be given the variation, like the limit will be varied from minus L by 2 to L by 2. Still, what is the effect of the variation of limit on the energy? The energy remains same, because energy depends on the value of L. So wave function will vary. Energy stays same. So this can be asked. They can vary from L by minus L by 3 to plus L by 3. So the variation in the L values and the its effect on the wave function and energy can be asked. Like how does that vary? The second is normalizing the wave function and the energy value of the wave function. You can be given a wave function, like it can be given as psi of x is equal to a sine n pi x by L by 2. So they are varying the L by 2 value. So you might be asked to derive the normalization constant based upon the L value. So as I said in the earlier part, the normalization condition is very important, and you have to learn to derive that. So these two can be combined and asked. Third is the extension up to the 3D box, energy and wave function of 1D, 3D and 2D box. The extension where they have the two conditions, a cubic box or square box in the case of 3D and 2D respectively, or a rectangular or a cuboid. So these are the conditions, basically the two conditions in 2D and two conditions in 3D. So you can be asked to find the energy, that is the expressions are there, nx square plus ny square plus nz square h square upon 8 ml square. This is for the cubic box, and respectively for the square box and rectangular box and cuboid box you might be asked. So these are this, and also इसमें एक और इसमें एक और पॉइंट आता है जो कि होता है degeneracy का. Degeneracy of levels can be asked. You might be given like the energy of a 2D box is given as 10 h square upon 8 ml square. This is a square box. So 10 is equal to nx square plus ny square. So you can make the possibilities like n can be is equal to 3, nx is equal to 3 or ny is equal to 1, and the vice versa can be true. So these like इसमें degeneracy क्या है और जो energy levels क्या आएंगे आपको वो भी पूछ सकता है. So this is a good question that is asked, and you might be given to plot the energy levels also based upon the degeneracy. Calculation of probability between a particular values, like इसमें आपको वैल्यू दे दी जाएगी जिसमें आपको मतलब पूछा जाएगा कि 1D बॉक्स का है तो उसकी प्रोबेबिलिटी निकालिए इन दो पर्टिकुलर इंटरवल्स के बीच में. जो हम प्रोबेबिलिटी निकालते हैं इंटीग्रेशन ऑफ साई स्टार डी टॉ, तो इसमें आपको लाइक रूट 2 बाई एल साइन एन पाई एक्स बाई एल. अब एल की वैल्यू उसने वेरी कर रखी है तो यहाँ पे इसका स्क्वायर हो जाएगा, डी एल हो जाएगा, लाइक डी एक्स हो जाएगा. एक्स विल वेरी फ्रॉम एल बाई 4 टू L by 3L by 4. Okay, so you would need to calculate this value. The quantization of energy levels, like as I said before, you might be given the values of a particular energy of a 3D, 2D or 1D box. You might be asked to calculate the degeneracy of a particular energy levels that are given for a particular value of energy. So you can calculate like the nx square plus ny square. If this the 3D box and nz square also will add you h square upon 8 ml square. So they can vary this value and ask you the degeneracy. So you can calculate as per the previously shown example. Questions based on quantization of energy levels in 2D or 3D box. इसमें quantization कैसे होती है? In the SHO model, you might be asked to write the Hamiltonian operator for the SHO. This is a very important question, and this has been asked 1 or 2 times in the previous year questions also. So you need to learn the Hamiltonian operator for the SHO, and also write the energy value for the nth level, and also focus on the 0 point energy. We know that the energy level is n plus 1 by 2 h nu. Okay, so you might be asked to find the value, give you HCl. They'll give you the mass of H is equal to 1 and Cl is equal to 35.5. So you'll be asked the value for the SHO model for the first excited state, let's say. So n will be 1 over there. Okay, n will be 1 over there, and you'll be asked to calculate the value of nu indirectly, and nu is 1 by 2 pi root k by mu. So with this and then reach up to this, and then put this value into this, and then calculate the energy eventually. The energy level can be varied, and you will be asked accordingly. The fifth is a rigid rotor model. Here you will be asked to give the energy expression. Energy expression can be directly asked or can be asked according to the given the values might be given, and you will be asked to calculate the energy. And Schrodinger equation in the Cartesian coordinates. This is a previous year question only that have been asked. So next, moving to the hydrogen atom model. In this you might be asked about the Schrodinger wave equation of the hydrogen atom. That is psi r theta phi is equal to r of r theta theta phi of phi. Next is the expression of r of r theta of theta phi of phi. This is an important part. You might be asked about the average distance from the nucleus. You can be asked to calculate the average and most probable value of the electron from the nucleus. So this contains the expectation value and the most probable value. For the most probable value, you differentiate the expression of psi with respect to r to get the most probable value. and the expectation value is also asked. So expression of expectation value is given here. So you can calculate using this equation, and if it is normalized, then this equates to 1, so it gets cancelled eventually. So you'll be asked to calculate this. This is the long problem, so you can practice this beforehand to get a idea of this. Next important part is the plots of psi of r versus r, psi of r square versus r, and the radial probability distribution curves. So you might be asked to draw the graph of this psi of r square versus r, and psi of the probability distribution curves. So you need to draw these curves as well. Like this is the curve for 1s, and respectively for the others, and also mark the number of nodes that can be found using this. Next is the energy expression of hydrogen atom. The hydrogen atom and hydrogen like atom, the energy expression, what is energy expression? So you need to remember that, and also like that is minus 13.6 z square upon n square. So that is the electron volt, and also in the joule also. So you need to remember the energy expression, and also they can ask for different energy levels and the energy values. This is a important part. The Schrodinger equation for hydrogen like atom, they can ask the Hamiltonian operator. So you'll need to consider a nucleus, and then the electrons, the multi-electron system, and the attraction between all the components. This is a big equation, so you can practice it beforehand for a better idea. We ignore the contribution of nucleus as it is considered stationary because it is heavy. This is the important part, as this can be asked in the short notes also that I will discuss further. So Born-Oppenheimer approximation is the theoretical also, and the application in the calculation of Hamiltonian of the hydrogen-like atoms also. Next, the last is the covalent bonding, the LCO-MO approach for H2 plus and H2, and the LCO-MO approach for LiH and HF. The diagrams are very important for these both, as this is explicitly mentioned in the syllabus. You can also these are the topics wise. There is also a question that is asked in your exam, that is titled short notes. First are the postulates of quantum mechanics. This is a theoretical question. There are 4 or 5 postulates, the statement also, and the equation that they state also. Okay, so next is the Pauli exclusion principle according to the quantum mechanical approach. Okay, third is the Heisenberg uncertainty principle. So as I said, the xpx commutation that was mentioned here. So xpx don't commute, so we say that the Heisenberg uncertainty principle holds true, as it states that the position and momentum can be calculated simultaneously. The fourth is the variation approach. This is from the covalent bonding wala section. So you can mention the equations for the psi A and psi B using C1, Phi 1. Next is the Born-Oppenheimer approximation. The reason of Born-Oppenheimer approximation and its application in the calculation of Hamiltonian of multi-electron system can also be mentioned in the answer. This is a part of chemical bonding section only. So this can also be asked. So in this video, I have mentioned all the important topics that have been repeatedly asked in the previous year questions and previous year papers. If you want to refer to the previous year question papers, I will be sharing them on the Telegram channel. You can join it using the link given in the description and in the pinned comment. So also I will be sharing this whole PDF on the Telegram channel, so you can have a look and revise using this PDF from there also. Thank you so much. That's all for this video. I'll see you in the next one. Bye bye.